So what we have been taught, will be talking today, is that branch of chemistry that is known as the organic chemistry. Organic chemistry is a branch of chemistry that deals with molecular compounds that have carbon on it. So any molecular, you know now that we have two types of compounds, one that is ionic compound when the electrons are transferred, and one that the electrons are shared between two or more elements in the compound. Uh, so organic compound focus on the molecular form of the uh, compounds, meaning that what is happening is that the electrons are shared. But it is important to state that the organic compound have, even though that they are molecular compound, have carbon on it, and usually have carbon and hydrogen, which is like the basic of the organic compound. But but there are cases that there are other elements as well within the compound, like oxygen, nitrogen, and chlorine, and all that those other elements on the compound. Uh, Even though that we are dealing with elements that have molecular compounds that have carbon on it, so when you see a compound that is a molecular and has a carbon on it, then you may think that, oh, this is the subject of organic compound. There are some exceptions. And you know now with chemistry, like in every science, you have a general rule and then you have some exceptions. So uh, if the organic compound is the study of molecular compound that have carbon on it, there are those exceptions. There are some exceptions, and there are four exceptions that we consider that not as a subject of organic chemistry, because they are not considered organic compound. Is the first one is oxides. So when we see oxides, let's say carbon oxide, monoxide, or carbon dioxide, we see carbon on it, but since it is connected with, or it's bonded with, an oxygen or two, like in this case here, then we do not consider them as organic compounds. The other exception that we uh, have for not considering them as organic compound are the one that are known as the carbonate. So carbonate are, you see, is one of the carbonate is the polyatomic ionic in your data booklet is CO3 -2. Okay, so everything that is formed as a result of this carbonate, let's say sodium carbonate, then we'll have Na2CO3, then it's considered to not be an organic compound. Okay, another one is that when we have the third exception that we have when we are looking at the is it an organic compound or it is not, is when they have cyanide. So cyanide again is polyatomic ion that is Cn minus, and everything that like has this polyatomic as part of the compound, even though that we have carbon there, we do not consider it as being an organic compound. And the last one is that is known the group of carbides, when the carbon is bonded with a non-metal. So let's say carbides. An example of a carbide is, let's say, silicon carbide. So even though that carbon, which is like the main thing, the main thing that we look at to define if it is an organic compound or if it is not an organic compound, that is having a carbon in a molecular compound. So now those ones here, those four situations or those four cases, when we have an oxide, which is, it can be in two forms, either carbon dioxide or carbon monoxide, or carbonate when the CO3 negative 2 ion is part of the compound, or cyanides when the polyatomic ion Cn negative 1 is part of the compound, or carbides, which is the group of compounds, so that is a carbon and it's a metal or non-metal, but usually is non-metal. Does it make sense of the exceptions that we have here? Okay. So let's take a look now to some examples. So when we have, and we are identifying if it is an organic compound or if it is not an organic compound. When we have this as the compound, what do you think? Is it an organic compound or it's not an organic compound? Now, since we have carbonate here, carbonate is one of the exceptions that we had, so therefore is not organic compound. Good. Next one is HCN. Is it an organic compound or it is not an organic compound? Now, one of the exceptions was cyanide, meaning that if we see in the compound, the CN, then we will be able uh, to say that this is not an organic compound. Let's take a look now. So this is not organic compound. Let's take a look now to carbon dioxide. We said that oxides, like things like carbon monoxide and carbon dioxide, is not an organic compound. Okay, how about C2CL4? Is this an organic compound or it is not an organic compound? What do you think about this? So what do you have to see, even though that this is the very first few minutes that we are working on organic unit, the exceptions are those four for being or not being an organic compound. So if the compound that you are looking at is not part of the exception, then it is a organic compound. So in this case, what we will see later on in the unit, that yes, this is an organic compound because the carbons the carbon is bonded with between the two in a double bond, and then we have or a triple bond, and then we have two chlorine on each of the carbons. So this is an organic compound. And always think about when you are defining if it is an organic or it's not, is it part of the exception or not? Next one is when we have this. So we have seen this, but now on this unit, we will even learn as to how can we name it and what is the structure of those weak acids as we saw it on the previous unit. So now we have carbon and then we have a bunch of other things. Are those other things part of the exception that we have here? So is this an oxide? Is this a carbonate? Is this a cyanide? Or is this a carbide? None of them is exception. So therefore, this is considered to be an organic compound. Next one is C6H12O6. You probably remember this from the previous class, previous courses of chemistry, and even from the previous unit that we did in chemistry 30, that is thermochemistry. This is glucose. So now, when you take a look at this compound, is this part of the exception? Yes or no? Meaning that Is this an oxide? So is it a carbon dioxide or carbon monoxide? Is this a carbonate? There is a CO3. Is this a cyanide? Do we have a CN there as combined together? Or is this a carbide? Is carbon connected or bonded with another element? None of them is part of it. So therefore, you are considering this as a organic compound. So now when we take a look at the other one, let's say that it's C2H5OH. Again, the same question. Is this compound part of the exception? No, therefore becomes, or it's considered to be an organic compound. What about C4H8O2? Is this part of the exception? No, then it is an organic compound. How about this, which in an IUPAC will be saying it's a calcium dicarbonate or calcium carbide. What is this? Is this part of the exception? Yes or no? It is part of the exception, so it is not considered to be an organic compound because carbon is bonded with another element, and those are known as the carbides. And the last one is CIS. Yeah, CIS. Is this a carbide? Yes or no? Is carbon connected, is bonded with another element? We actually have that example there. It is not organic compound. Does it make sense, guys? So now let's have a short review as to what is happening in terms of the carbon. Why carbon in an organic compound and organic chemistry is such an important element. So when we take a look at carbon, what do we know and what you hopefully remember from chemistry 20 and even science 10, you saw that if we are drawing the Lewis diagram of carbon, then you will have something like this. Carbon is here, and then you will have one electron on four sides that the carbon has. So up, down, left, to right. Okay, so this is telling us that what do you have here? You have four possible bonds. The carbon is one of the elements in the periodic table that has four possible bonds. What is happening when we have those possible bonds is that if one element, let's say hydrogen has only one electron in the outer shell, meaning that it has one possible, is able to create one bond. And since it is on the first group and has only one shell in the structure, then maximum of electrons that hydrogen can hold is 2. So when carbon is meeting, quote unquote, hydrogen, what is doing is saying, okay, let's bond together. So carbon is saying that, okay, hydrogen will come here and will form a double bond, not double bond, but will form a bond with hydrogen. So one of them is coming from carbon and the other one is coming from the hydrogen. And then if we have four hydrogens, then four of them will be bonded with carbon like this. And then on this way, what is happening is that hydrogen will be satisfied in the outer shell having those 2 electrons. This is the maximum that hydrogen can hold. All the hydrogens will be happy because they have those outer shells completed with 2 electrons. And on the other hand, what do we see is that carbon as well is satisfied because in the outer shell it has 8 electrons, and on this way it's completing that is known as the outer shell, or eight electrons in the outer shell, or the octet rule of the electron. So the fact that carbon has some electrons in the outer shell which are able to, or they want to be bonded with another element, makes the carbon very attractable toward the other elements. And then what is happening between carbon and the other elements, like in this case, when we have CH4, what is happening in with the carbon and the other elements, they are all happy, but the electrons are shared between each other. So meaning that those 2 electrons here are shared between carbon and hydrogen. They are shared like this, carbon and hydrogen. And those 2 electrons here are shared between carbon and this hydrogen here. We will not go into details into um, Vesper, what we have seen, you have seen in Chemistry 20, into defining the angles and all that stuff. However, just keep in mind that when we see this, this is the like this is how those compounds, organic compounds, are formed. But if we have a formula, let's suppose that we have a formula like this, C2H4. So the fact that we have 2 carbons means that those 2 carbons are connected between each other. Oh, now, if we go back here, usually we do not represent this bonding with dots, like in Lewis diagram, but what we do is we present the bonds with lines. So what we see is something like this. And this is known as the structural diagram. So those lines represent a pair of electrons. Okay, so now since we have 2 carbons, we start that is known chain in chemistry, organic chemistry, with 2 carbons. But each carbon we saw that has 4 possibilities to bond. So we'll go 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. So now if you take a look at the first carbon, you will see 1, 2, 3, 4 bonds. And then if you take a look at the second carbon, will be 1, 2, 3, and 4. So this pair of electrons, or this bonding here, is shared between the 2 carbon. Now let's take a look at the hydrogen. We said that we have 4 hydrogen here. The formula is telling us that we have 4 hydrogen. So let's suppose that we have 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, and 1 here. Now you may say, why didn't you complete the first carbon with 3 hydrogens and then leave the rest of it? Because you have to be fair. Both carbons are the same. You do not make any favorite. You do not say that carbon 1 is favorite, so I will complete that first. You complete one, they complete the other. You complete, if you have more than 2, then complete the third, and so on. So now, when do you take a look at the bonds here, you notice that this bond here are free. Those 2 bonds here are not. What is happening with this bond here and with this bond here? We do not have hydrogen. How come that we don't have hydrogen? Because we have only 4 hydrogen to place into the outer shell of carbon. So then what is happening is those 2 bonds are forming between the 2 carbons that that is known as the double bond. So what is happening, those two bonds are kind of disappeared from being as looking for another element to be bonded with. They say, since we do not have any other element to be bonded with, then let's bond together into a double bond. And this is how the double bonds are formed into uh, um, into between the two carbon. And this is kind of a review from Chemistry 20, but just keep this in mind. Now let's take a look at another compound. So I'm telling you that the formula of a compound is this one here, C2H2. So this is telling you that you have two carbons and you have two hydrogen. So let's see the mechanism that it is, the bonds are formed between the carbons and between the hydrogen. When you are working with drawing any structural diagram, you start with the main, the element that has the most bonding capacity. So those four bonds that we said for carbon, it's known as the bonding capacity. So four electrons in the outer shell able to connect with four elements. So now the first carbon is connected with a second carbon, but each carbon has four. So 1, 2, 3, 4, and then 1, 2, 3, and 4. Okay, now it is said here that we have only two hydrogens. So I will place one here and one here. Let's see now what do we have. We have on each carbon, we have two bonds that are free. They do not have any element to bond with. Therefore, what they do, the same logic as we said for the double bonding, they are saying that, okay, let's forget about the other elements. Let's connect between each other. So those two bonds that were at the top are connected with the two carbon to form the double bond. Okay, and then is saying that what about those two others that you have here? What will we do? The same thing. Then those two bonds are disappeared, quote unquote, and then they are formed, they are connected, they are bonded between the two carbons, which are the they have the highest bonding capacity. And then on this way, you see that each carbon has four, because you have 1, 2, 3, 4, and then the other carbon the same thing, 1, 2, 3, 4, and the hydrogen has two, because the hydrogen can hold only two. On this way, the triple bond between the two carbons is formed. The way that we represent this in the Lewis dot diagram is something like this: carbon 1, 2, 3 bonds, another carbon here, and then you have a hydrogen here and a hydrogen here. Does it make sense? Before we go to naming, I want to talk about the types or the way that we communicate that we are dealing with an organic compound, or the way that we communicate into organic chemistry. So when communicating is showing what are you talking about, what is the compound that you are talking about. So the very first way that we communicate in organic chemistry is using molecular compounds, molecular formula. So when we have something like butane, with the chemical formula C4H10, then when we see this, that all carbons are together, all hydrogens are together, or all oxygen, if there is any, are together, or all chlorines are together, when you see a compound formula, then this is known to be expressed as the molecular formula of the compound. However, the second way of expressing and communicating the compound, the molecular compound, is using that is known as the expanded molecular formula. In the expanded molecular formula, what you are doing is you are showing how many starting with carbon, because organic has carbon on it, starting with the first carbon, how many elements and what are the elements that are part of it. So in the case of butane, you have on the first carbon, you have 3 hydrogens, okay, because you have carbon and then you have one bond is connected with the second carbon, and then you have 3 bonds that hydrogens are bonded with. So on the first one, you have 3 hydrogen. On the second carbon, you have 2 hydrogen. On the third carbon, you have 2 hydrogen. And on the fourth one, you have 3 hydrogen. So because of the structure, so you connect the carbons between each other, and then you see that you have 3 hydrogen on the first and the last carbon, and then 2 hydrogen on the other carbons. The third way that we communicate with expressing what is the organic compound is that is known as the structural formula. So even when we do the structural formula, as we did before for methane, you will see and will make more sense why do we have this as the expanded molecular formula. So since we have 4 carbons, then we say carbon 1 is connected with carbon 2, connected with carbon 3, connected with carbon 4. And then each carbon has 4. So 1 is here, 2, 3, 4. 1 is here and 1 is here, 2, 3, 4. 1 is here and 1 is here, 3, 4. 1 is here and 3, 4, 2, 3, 4. Okay, so now we are placing hydrogen. We have 10 hydrogen to place at. So we start hydrogen 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, good. So all hydrogens are placed. All carbons are satisfied with 4, and all hydrogens are satisfied with 2. And this is known to be the structural formula of the compound. Okay. Next way that we communicate the organic compound is that is known as the condensed structural formula. So on the condensed structural formula, we do not have those hydrogens all over, but we condensed structural formula. We do not have those hydrogens spreading around like we have in the structural formula, but we have only combining all whatever has the carbon into one and showing just the bonding between carbons. So on this case, we'll have carbon here, and then the carbon has 3 hydrogen, which is connected with another carbon, the second one that has 2, which is connected with another carbon that has 2, and the last one has 3. So this way will be the condensed, this way will be the condensed structural formula when you are kind of showing the structure, but not full of it. Because you are assuming that on the first you have 3 hydrogen, on the second you have 2 hydrogen, and so on and so forth. The last one, which is used, and we will see it and we will use it very often, is that is known as the line structure. In the line structure, we are just drawing the lines, assuming that at the vertices of each, we will have carbon with whatever branches we have. So in this case, will be something like this: 1 carbon, 2 carbon, 3 carbon, 4 carbon, and that's it. Now, when you see this, the assumption that you do is that you will have hydrogens all around. And we don't even say that on this one is a carbon. We just draw a dot and then we assume that it is carbon on it. If it is something else besides hydrogen, then we will state it as to what is it. But if it is just hydrogen, then we will leave it like this. In between of those carbons, what do we have is that is known as the tetrahedral bonding. We will not go into details into this because you have done this in chemistry 20. Does it make sense? Good. Let's see now for whatever we did here, the molecular formula, the expanded molecular formula, structural formula, condensed, and the line structure. Let's see how will we do, let's suppose propane. The formula for propane is C3H8. Okay, so this is the molecular form of expressing the compound. Now, how about the expanded molecular formula? Now, when we are saying expanded molecular formula, you have to think what is happening with the first carbon. How many hydrogens are in the first carbon? How many hydrogens are on the second carbon? Because you have 3 carbons here. And how many are on the third carbon? So what do you think? How many hydrogens are in the first carbon? Carbon 1 and carbon 2 are connected together, so 1 bond is gone. How many bonds are left? Yes, CH3. Even if you say H3C is fine, is the same thing. It's not considered to be wrong. On the second carbon, so on the second carbon you have the second carbon is connected with the first and the third carbon. So 2 bonds are gone. How many bonds are left to be placing the hydrogen? CH2. So there are 2 hydrogens in the other 2 bonds that are left. And now we move to the third carbon. On the third carbon is bonded with the second carbon, so 1 bond is gone. And there are 3 bonds that are left. We have to fill that with the hydrogen, so we will have CH3. And this will be the expanded molecular formula. Make sense? Now let's take a look at the structural formula. So we have here the third way of communicating it is the structural formula. So we have 3 carbons. You always start by writing carbons down because carbons has the highest bonding capacity. So carbons will be the one that we will write first. And then each carbon has four. So 1, 2, 3, 4 for the first one. 1, 2, 3, 4 for the second one. 1, 2, 3, 4 for the third one. And then on those free bonds, free quote unquote, we will place hydrogen. So hydrogen, 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 and hydrogen. And then even if you count, you will have eight hydrogens. So this is known as the structural formula. Okay, let's move now to the condensed structural formula. So on the condensed structural formula, we will connect the carbons between bonds. We'll show that carbons are connected between each other with a bond, but we will not show the hydrogens or the other compounds or the other elements. So we'll have CH3, and then this is bonded with, I will just erase this. This is bonded with CH2, and then the last one, CH3. And this is condensed structural formula. Okay? And the last one is the line structure. So what do we have for the line structure is we have 3 carbons. So we'll start 1 carbon, 2 carbon, 3 carbon, and that's it. The line structure is very easy, and this is why it is often, very often is used into showing, communicating the organic compound. And the line structure, we do not have any we do not represent any hydrogen. We assume that they are hydrogens and the bonds are completed, but we just go with like um, a line that goes up and down like this to show that on each of those vertices and the starting and ending points, we have carbons.